Okay, hello guys. Today we will start a new chapter, that is thermometry, thermal expansion as well as the kinetic theory of gases. Today in this session we will discuss about thermometry and thermal expansion of objects, that means solids, liquids and gases. Okay, let's start. Thermometry. Now, what is meant by thermometry? Here there are two words, thermo and metry. Thermo means temperature. Okay, it is temperature, and metry means measurement. Okay, it is the measurement of the temperature. It is the measurement of temperature. Okay. Now we have three types of scales. That is Celsius, and Fahrenheit, and the third one is Kelvin. Okay, Celsius, the range is from 0 to 100, and Fahrenheit is from 32 to 212, and Kelvin is from 273 to 373. First, we will write the relationship. To write the relationship, we want to write T higher minus T lower upon difference. That means, okay, here it is x upon T higher minus T lower. For the Celsius, x is equal to C. Lower means 0 upon T higher. T higher means 100 is equal to F minus 32 upon, say the difference is 180, and the third one is Kelvin, K minus 273 upon T73 minus 273, it is 100. This is the relationship between these three. Now we will derive the relationship between Celsius and Fahrenheit and Celsius and Kelvin. First we will derive for Celsius. C by 100 is equal to F minus 32 upon 180. So the 0 are cancelled, and it is 2 5s are, and it is 2 9s are. So 9C. Okay, 9C is equal to 5 into F minus 32. Now C, okay, C is equal to 5 by 9 into F minus 32. It is F minus 32. Okay. Now we got the relation between Celsius and Fahrenheit. Now we will derive the relationship between Celsius as well as the Kelvin. Now I will write here, that is 1. I will write C by 100 is equal to K minus 273 upon 100. So at the denominator, 100 and 100 are cancelled out. So C is equal to K minus 273. Okay, now we got the Celsius and between the relationship between Celsius and Kelvin and Celsius and Fahrenheit. Now we will write the relationship between Kelvin and Fahrenheit. Okay. Now we got this 2, K minus 273 and 9, 5 by 9 into 32. So I will write here K minus 273 for relationship between Celsius and Kelvin is equal to 5 by 9 into F minus 32. So it will go here 9 into K minus 273 is equal to 5 into F minus 32. Okay, this is a very long relationship, so you can neglect it out. So the two are C is equal to K minus 273. Okay, and C is equal to 5 by 9 into F minus 32. This is the relationship between Celsius and Kelvin and Celsius and the Fahrenheit. Okay. Now, what is the temperature? How we can find out the temperature range? First, copy this. Okay, now let's discuss the temperature. What is the error in the temperature? Okay, I will write here. Okay, now there is a particular temperature T. T is equal to Xt. That means unknown temperature we want to find out, minus X0 upon X100. That means at 100 degrees or at the last end point, it is X0. Now T. What is the means by T? T means at the temperature of the body. Temperature of the measured substance. Measured object we can say. Okay. Now Xt. Xt means temperature given by the Celsius or Fahrenheit or Kelvin temperature of thermometric scale. Or we can say it simply temperature given by thermometer. Okay. Now X0. Initial value and X100 final value. I think it is visible to you. Okay. Now there is a temperature T of the object. Suppose I am the object. My temperature is 37. So the temperature is 37, and we have taken the Celsius scale 0. Here 0 upon 100 minus 0. Now, if the thermometer gives the more than or less than this temperature, so the thermometer is fault or there is an error in the thermometer. Or if the liquid is equal to the body temperature, then the temperature will be same. So let's solve a problem to understand this case. Okay. Okay, let's solve a problem. Now, the steam point and the ice point of a mercury thermometer are marked by 80 degrees and 110 degrees Celsius. So, at what temperature? At what temperature on the centigrade scale the reading of thermometer will be 59 degrees Celsius. Okay. Now in the question, there is a mercury thermometer that measures, that has a 80 degrees at the initial point and 110 degrees at the final point. Now they are comparing the mercury the thermometer with the given values and that of Celsius 1. Okay. Now we will compare, that is x t minus x naught upon x 100 minus x naught is equal to, here C minus 0, because the temperature of the Celsius scale is 0, initial one. 100 minus 0. From this, xt is 59 minus this 80 upon x 100 means 110 minus 80 is equal to C, that means first Celsius upon 100. So by solving this, we can get our different answer. So it is the 21, I think so. 80 minus 6 is 20. 20 plus 1 is 21. So it will become 21 upon 30 is equal to C upon 100. So now this and this one is cancelled out. So C is equal to 70 degrees Celsius. So at this temperature, the thermometer, a mercury thermometer reads 59 degrees Celsius. Okay, this is the point. Let's check our answer is correct. Yes, we got the right. Okay, this first suppose if they have given the values, okay, this is the one we want to solve. Now let's check, either it is 59, yeah. Okay, now we have completed the thermometry. Now we will discuss the different types of the thermometers. There are three types: mercury, thermometer at constant pressure, constant volume, and the relative thermometer as well as the pyrometer. Let's read that. First, copy this. Okay, let's read. We will read by comparing one. Okay, in a comparison way. So if you read in a comparison way, it will be more easy to remember. For suppose the temperature, it is the temperature, final temperature, and it is xt. I have said x naught upon x 100 minus x naught. Okay, now we want to read for mercury thermometer, platinum resistance thermometer, okay, as well as the thermometer at constant pressure and constant volume. At constant pressure and at constant volume. So let's read. For here it is L, length, and for resistance it is R. Now for this one it is C, or we can say it is P, pressure. It is V. Okay, now let's write the values. T is equal to LT minus L naught upon L100 minus L naught. In the same way you can write for these three. Okay, I will write T is equal to RT minus R naught upon R100 minus R naught. For pressure, T is equal to PT minus P naught upon P100 minus P100 naught. For V is T is equal to VT minus V naught upon V100 minus V naught. Here it is V. So in this way we can find out the temperatures by using mercury thermometer, platinum resistance thermometer, and thermometer at constant pressure and thermometer at constant volume. So we have one more thermometer that is not based on these values. It is called pyrometer. So pyrometer is used to determine the temperature of some varying degrees. And this for calculating the temperatures of the bodies like sun, moon, or celestial bodies. It is used to find out temperature of some celestial objects. Okay, now we will solve some problems using this 1, 2, 3, 4 cases. Okay, first copy this. Here we want to multiply because If we cannot multiply, the values will become wrong. It will become in the points. Okay, now let's solve some problems. After that we will continue the next topic. Okay, now we will solve some problems. That is, first problem related to this. The pressures of the gas filled with gas filled in the bulb of a constant volume. So constant volume, gas thermometer are 66 centimeters and 88 centimeters of mercury column at 0 degrees Celsius and 100 degrees Celsius when its bulb is immersed in a liquid placed in a vessel. Its pressure is 82.5 centimeter of mercury column. Calculate the temperature of liquid. Okay, now in the question they are saying that there is a constant volume gas thermometer. So the temperature is Vt minus V naught upon V100 minus V naught into 100 degrees Celsius. So if you follow this, we can receive 0 marks. So we will receive the temperature is Pt minus P naught upon P100 minus P naught into 100. So we will write down what they have given in the question. First, P naught. What is the value of Pt? It is 82.5. And P naught. P naught is it is at 66 degrees Celsius. Now P100. P100 is 88. So the temperature is T is equal to Pt. It is 82.5 minus 66 upon P100 is 88 minus 66 into 100. So it will become, for example, if you put a point here, 0.5, if to get the values easier. So 0 point, now it is 6 and it is 16. So it will become 16.5 upon 22 into 100. So this is the temperature you want to find out. Let's check. Yeah, now it will become on calculation it will become 75 degrees Celsius. So this is the simple form question. So if you solve this by using this formula, we can get this. Now let's see the next question. Yeah, the next question is so easy, like this type, but different type of thermometer. First, copy this. Okay, let's read the second question. Okay, the second question. What the second question states? The following observation was recorded on a platinum resistance thermometer. So what is the one that strikes your mind? It is T is equal to RT minus R naught upon R100 minus R naught into 100 degrees Celsius. This will strike your mind. Yes, it is true. Yeah. Now we have another one. The other one is alpha. Alpha means the temperature coefficient. Alpha is equal to R100 minus R0. So it will come here upon R. It is RT into 100. I think it is correct. Here it is R0. It is the temperature coefficient. Why I have not said this one? Because you will read in a problem like this one. Okay. Now let's discuss the remaining part of the problem. Now they have given R at 0 degrees Celsius, that is 3.7 ohms. Now R at 100 degrees Celsius, that is 4.71, or we can say 4.7. Now R T, it is 5.3, we can say ohms. Now we want to calculate, that is alpha is equal to dash, and the second one is the T is equal to dash. So you can solve by using these two. First you try, after that I will try. Okay, you post in the comments either you got right answer or wrong answer. So let's start. Pause your video. T is equal to, here RT is 5.3 minus it is 3.7 upon it is R100 is 4.7 minus 3.7 into 100. Now it will become 1.6 upon 1 into 100. So it will become 160 degrees Celsius. Okay, if you want to find out in Celsius, you can get the temperature. So we have got the temperature. I hope you got the temperature at 160 degrees. Now alpha. Alpha is equal to R100 is 4.7 minus 3.7 upon 5.3 into 100. So it will become 1 upon 530. It is the alpha. So we can write alpha is equal to 1 by 530 is the alpha, and the temperature is 160. So we can write 1 by 530. Or the temperature is 160 degrees. So we will check whether our answers are correct or not. Okay. But the original question is it is 4.71, but I have written this slide. So our answer is correct. This one, yeah, we are also right. Oh, there is a small mistake here. Here it is R naught, but we have taken RT. So R naught is 3.7. So it will become 370. Okay. So you want to look the question carefully before attempting the answer. So this is the one mistake I have done today. Now first copy this, then we will read the next question. Okay guys, I hope you have completed this problem. Now we will read the thermal expansion of objects. First we will solids, after that liquids, after that gases. So let's start the solids. Okay, now thermal expansion. Okay, now what is meant by thermal expansion? It is the expansion of objects. That means object will expand. Expansion of objects when they are heated. So if the objects are heated, they will expand because of intermolecular collisions. So it is due to the intermolecular collisions. Now we have three types of objects, that is solids, liquids and gases. Now we can remember that solids have linear expansion, that means expansion in length, areal expansion with expansion in area, and volume expansion. But liquids and gases have only volume expansion. In the today's session, we will end up this session with solids. The next session we will start with liquids and gases. Okay? Liquids, areal expansion. Solids, it has linear expansion, areal expansion, and volume expansion. First we will see the linear expansion. Linear expansion. Linear expansion means expansion in length. Of length. Okay. Now expansion of length. So it will LT. That means the temperature T is equal to L naught, an initial temperature, into 1 plus alpha. What is meant by alpha? Coefficient of linear expansion into delta T. So LT means, now I will write what they have given. LT. LT means length at temperature T. Okay. Now L naught. L naught as initial length alpha, coefficient of linear expansion, and delta T. What is meant by delta T? It is change in temperature. Change in temperature. Okay, these are the ones. Now to get the alpha, we have one, that is alpha is equal to LT minus L naught upon L naught into delta T. This is the alpha. Okay. Now what is the units? It is Kelvin inverse. Units are temperature to the power of -1 or K to the power of -1. These are the units. Now we have completed discussing the linear expansion. Let's discuss about the areal expansion. Areal expansion is also same, but this is area. I forgot to draw the diagram. This at 0 degree, for suppose. Now it is at 0 degrees. Now it is total at 30 degrees Celsius. So this is L naught and it is LT. So this is the increases. Okay. Now let's discuss the areal expansion. So this is the area of this rectangle. It is an initial. So if we apply T, it will expand. It is at 0 degrees. It is at 3 degrees. It is area A and it is area A. So it is A naught and it is AD. So linear expansion means expansion of length. Sorry, it is area. Now it is area 1. So AT is equal to A naught into 1 plus, here in the place of alpha, you can write beta or 2 alpha into delta T. Now 2 alpha is equal to AT minus A naught into delta T. Or you can say beta. the diagram and the units are same. Temperature inverse or Kelvin inverse. Okay. Now let's read about the volume expansion. First copy these two. Okay, let's discuss the volume expansion. Volume means expansion of volume. So it is for 3D objects, 3-dimensional objects. So it is twice that of alpha. Volume expansion. That means expansion of volume or change in volume. So, suppose this is a cube. I have drawing now. This is a cube. This is a V0. And initial temperature. Now, at final temperature, it is Vt. It at final volume. At final value at temperature T. Okay. Now, we have the relation Vt is equal to V0 into 1 plus 3 alpha, we can say. 3 times of alpha, it becomes volume into delta T. Now, what is the value of 3 alpha? 3 alpha is equal to Vt minus V0 upon V0 into delta T. Okay? V0, 3 alpha means gamma and 2 alpha is beta, and we will write the units. Units are temperature inverse bar Kelvin inverse. Now we have a relation between alpha, 2 alpha and 3 alpha is equal to alpha, beta and gamma. Okay, these alpha and these alpha cancel. So the ratio of alpha, beta and gamma is 1:2:3. Okay, now copy that. After copying, we will start solving problems. Okay, let's discuss the problems. I am rubbing all, so you can, if you want to write, please pause the video as well as write. So do like, share and subscribe to our channel to get more information. Now, the first problem is steel, rubber, it is a ruler, not rubber, exactly 20 centimeter long. 1 minute, I will check, yeah, is graduated, that means it is increased to give correct measurements at 20 degrees Celsius. Okay, now it is exactly 20 meters square. So L naught is equal to 20 at temperature 20 degrees Celsius. Okay, now they are asking, will it give readings that are too long or short at lower temperatures? At lower temperatures, okay, now they are asking if the temperature are decreased. So if the temperature are decreased, now will it give readings are too long or that are too short? Answer is that are too long. Readings are too long. Readings are too long because as temperature increases or it will decrease, as in the question, as temperature decreases, the expansion due to thermal energy, the temperature decrease, so the one will also decrease due to decrease in temperature. Because the temperature decreases, the scale contracts. Okay, it gives contracts, and if it is below 20 degrees, the conversion into centimeter will increases. Conversion into centimeter increases. So due to this reason, it will expand. So it gives reading that are too long. Okay. Now second question. Let's see the second question. So second one is this one only. Actual length of the ruler. You want to find out the actual length of the ruler for which the temperature is 40 degrees Celsius. Now alpha is 1.2 into 10 to the power of minus 5 degrees Celsius to the power of minus 1. Now they are asking actual length. So it is L dash is equal to initial length plus expansion change in length. So if you find out the delta L, you can solve the L. Okay? L is 20 centimeter plus delta L. Delta L is equal to L alpha delta T. L is 20, alpha is 1.2, the temperature is 20 into 10 to the power of minus 5. So 20 into 20, 400, 400 into 1.2, 4.8. It is 400. 412 by 10 is 48. 48 into 10 to the power of minus 5. Okay, let's check whether our answer is correct or not. Okay, into 10 cubed. Okay. Okay, it will become 48 into 10 to the power of minus 5. So if you solve this, you will get the answer. First, copy this. This is the most simple question. But if you use your knowledge, you can easily solve this. Okay, let's read the next question. Okay, the second question. So before continuing, I will say that this is we can discuss the applications of thermal expansion of solid in the next session. So we will complete this session after discussing some problems. Okay, this is a note. So a metal ball. There is a metal ball. There is an area having a diameter of 0.4 meters is heated from 273 kelvins to 360 kelvins. Okay, this is the first part. Now there is a metal ball. It has the initial time 0.4 and it is heated from 273 to 360 kelvins. Now, if beta, they have given the area quotient of expansion, that is 0.00. They have given 40. 1, 2, 3, 4. Okay, Kelvin to the power of minus 1. Then determine increase in surface area. Now the question is so simple. Okay. Okay. Now if they have given delta T, first delta T is equal to 360 minus 273. For suppose it is 260, it will become 100. 100 minus 13, it is same. It is 87. Okay, this 87 Kelvin. Yeah. Now beta is equal to 0.000 another 034 Kelvin. It is Kelvin to the power of minus 1. Now diameter D is equal to 2R. So R is equal to D upon 2. Diameter is 0.4 by 2. So it will become 0.2 meter. Now area. What is the area of the ball? That is a sphere. So 4 pi R square. 4 into 4 by 100 into 3.14. Now I will write the value, that is 0.5024 meter square. This is the value. Okay. Now they are asking delta A. Delta A is equal to A naught into beta into delta T. A naught means 0.5024 into beta. What is the value of beta? 0.000123 34 into delta T, it is 87. So delta, if you solve this, you can get 1.486 into 10 to the power of minus 3 meter square. This is the area. So you can solve this by using this trick. Okay. In the question they have given the change in temperature, the initial diameter, converted into radius, and substitute in the area value, and beta they have given, and so we have to find out the increased surface area. So let's discuss the last two problems that are related to the volume of core expansion. So first copy this, then we will discuss the next one. Okay. Now let's discuss the next problem. That is so much easy. If you know the tricks to apply what we have given the question, you can think that I am preparing the answers, but I have practiced this. So I think it is 1, 2. Third problem. On heating a glass block, it's a glass block. Glass block means this three-dimensional object of 10,000 centimeter cubed from 25 degrees to 40 degrees Celsius. Its volume increases by, they are saying increases by. So the change in volume is 4. So you can directly write the delta V is equal to 4. Increases by 4 centimeter cubed. Determine alpha. So we want to find out alpha. So first we want to find out beta. Beta is equal to 3 alpha. So alpha is equal to the beta gamma by 3. It is gamma, not beta. So gamma is equal to delta V by V. Delta V by V into delta T into 1 by 3. Okay. So delta V is 4 upon it is 10,000. So 1, 2, 3, 4. So 10 to the power of 4 into here it is 15 into 3. So it is 45. So 4 into 10 to the power of 4 into 45. So this is the 1. This is the answer. So if you solve this, you will get the answer. Now, if you solve this, I think you have done. The answer is 8.89 into 10 to the power of minus 6 Kelvin to the power of minus 1 of we are given Celsius, so we are going to write out the Celsius. So it is alpha. Now let's discuss the last problem. Write down. I will draw a line here. Okay, fourth problem. Volume they are giving the volume of mercury in the bulb of a thermometer is 10 to the power of minus 6 meter cubed. The area of capillary tube is 2 into 10 to the power of minus 7 meter square. If temperature raised to raised to 100 degrees Celsius, find in length of mercury column. Now they have given gamma is equal to 18 into 10 to the power of 5 per Celsius. So first try this, okay, then I will solve, okay. Okay, now they have given volume is equal to 10 to the power of minus 6 meter cubed and the delta T is equal to 100 degrees Celsius and area is equal to 2 into 10 to the power of minus 7 meter square. Now we want to find in length. Find in length. What is increase? Find delta length, we can say. Increase in length. So delta L is equal to dash. So first we want to find out delta V. Delta V is equal to V into gamma into delta T. So V is equal to 10 to the power of minus 6. Gamma is 18 into 10 to the power of minus 5 into delta T. Delta T is 100. This is the delta V. Now delta V is equal to A into delta L. So delta L is equal to delta V upon A. Delta it is 10 to the power of minus 11. 10 to the power of minus 11 into 10 square is 10 to the power of minus 9. 18 into 10 to the power of minus 9 upon, what is the area? It is 2 into 10 to the power of minus 7. 2 into 10 to the power of minus 7. Okay? Then I will write here delta L is equal to 2 ones, 2 nines. 9 into 10 to the power of minus 2 meter. Another delta L. Okay? First I will cross verify this. Now, yeah, we have got the right answer. So, we have completed the part 1 of thermometry, thermal expansion, kinetic theory of gases chapter. Now, in the next session, we will continue with the applications and the one. So, that's all for today. Thanks for watching the video. And do not forget to like, share and subscribe to our channel Mahatma Academy. So, take care and bye bye.